This is the solution to number 33 from homework 4.2 day 1. In trying to graph this rational function, the first thing in our analysis is we need to factor the numerator and the denominator. The numerator you can factor using AC. I'm going to use guess and check. I know the first terms have to multiply to 2x squared, so I need 2x and x. The last two terms multiply to negative 3. I only have two options, negative 3 and positive 1, or negative 1 and positive 3. In this case, it's going to be negative 3 and positive 1. So I'm going to have 2x plus 1 times the quantity x minus 3. The denominator, I'm going to factor that by grouping. So grouping the first two terms, I have x squared times x minus 2. I'll factor out a negative 1 from the last two terms, so negative 1 times x minus 2. Then this factors as x squared minus 1 times x minus 2. X squared minus 1 is a difference of squares. It factors as x plus 1 times x minus 1 times x minus 2. Now that it's factored, we're ready to do the analysis. X-intercepts occur when the numerator is 0, but the denominator is not 0. The factor of 2x plus 1, this factor gives us a 0 at x equals negative 1/2. So we have negative 1/2, 0 with odd multiplicity, because 2x plus 1 only occurs once in the numerator. The factor of x minus 3 in the numerator gives us an x-intercept at 3, 0, also with odd multiplicity. The y-intercept occurs at f of 0. So f of 0, it's easiest to look at the unfactored form here. So f of 0 is going to be equal to negative 3/2. So our y-intercept is at 0, negative 3/2. Vertical asymptotes occur when the denominator is 0, but the numerator is not 0. We don't have any common factors between the numerator and the denominator. We don't need to worry about holes here. So we have three vertical asymptotes, one at x minus 1 from the factor of x plus 1, one at x equals 1 from the factor of x minus 1, and one at x equals 2 from this factor at x minus 2. These all have odd multiplicity. Infinite asymptote, we're going to look at the degree of the numerator and the denominator. Here, the degree of the numerator is 2. The degree of the denominator is 3. This is bottom heavy, which means we have a horizontal asymptote at y equals 0. In determining whether this graph intersects the infinite asymptote at y equals 0, all we need to look for is x-intercepts. I mean, that's what x-intercepts are. They're points where the graph crosses the line y equals 0. So we have two places, negative 1/2, 0, and 3, 0. If you didn't realize that, you could solve the equation 0 is equal to 2x squared minus 5x minus 3 over x cubed minus 2x squared minus x plus 2, which is what we did to find the x-intercepts. Let's put the skeleton on our graph. So I'm going to put on the x-intercepts at negative 1/2, 0, and 3, 0. Both of those have odd multiplicity, so I'll put a little O next to them. I'm going to put on the y-intercept 0, negative 3/2, and I'm going to go ahead and sketch in the vertical asymptotes. So we have one at x equals negative 1. It's odd. I'll put a little O above it. X equals positive 1. It's also odd multiplicity. And x equals 2. Also with odd multiplicity. And we'll put the horizontal asymptote of y equals 0. Okay, now to sketch the graph. I'm going to start at the y-intercept, so I know I need to pass through 0, negative 3/2. The x-intercept at x equals negative 1/2, 0 is odd. That means the graph has to cross the x-axis there. So if the graph is going to cross the x-axis there, it's going to be going in this direction. Then it's going to approach the vertical asymptote at x equals -1 and shoot up to positive infinity. I'm going to pass through the y-intercept at 0, -3/2, and continue down towards that vertical asymptote at x equals 1. When we go to the next vertical asymptote, let's go to the right of the vertical asymptote at x equals 1. X equals 1 has odd multiplicity, so if the graph is going down to the left side of x equals 1, that means it's going to be going up to the right side of x equals 1. And then, since I don't have any other x-intercepts, my graph cannot cross the x-axis between 1 and 2, so it has to turn around and go back up towards the vertical asymptote at x equals 2. X equals 2 has odd multiplicity, so my graph is going up on the left side of x equals 2. That means it's going to be going down to -infinity on the right side of x equals 2. But then we also have an x-intercept at 3, 0, which has odd multiplicity. So that means that the graph has to go up, and it's going to pass through that x-intercept at 3, 0. It's going to cross the x-axis there, but then as x goes to positive infinity, it has to come back down and approach the horizontal asymptote at y equals 0. We have one more section to look at. So we have to go to the left side of the vertical asymptote at x equals -1. So on the right side of the vertical asymptote at x equals -1, the graph is going up to positive infinity. When we cross over to the left side of x equals -1, since this is a vertical asymptote with odd multiplicity, on the left side of the vertical asymptote at x equals -1, the graph has to be going downwards. And then as x approaches -infinity, the graph has to approach the horizontal asymptote at y equals 0.